Dear friends, today we are going to see Poisson distribution. So Simeon Denis Poisson, who give an elegant formula of Poisson distribution. He was a French mathematician. So let us go into the session. So before going to the session, those who don't watch the previous videos, like first you just go and learn what is meant by distribution, why we need a distribution, and what is binomial distribution. The links are given in the description. You just click it, go and watch it. And secondary, it is very essential to know the calculator tricks and shortcuts to solve the problems right now at the videos as well as for your semester. So the calculator trick link is also available in the description. Click it, go and watch it and come back. And also subscribe our channel, support. It's of course it's our channel. Okay, good. Let's go into the session, guys. So Poisson distribution is a limiting form of binomial distribution. Okay, so that means a Poisson derived the formula from binomial as a limiting case. So what we are going to see, what are the conditions? So as usual, let us assume this random variable is discrete. The first point. The second point, what it is saying, when my probability of success is very low, that means it is tending to 0 but it is not 0, because if success is 0 no one will play the game, right? It is very low. For example, you will say number of accidents happened in a road where 10 lakh vehicles are traveling, something like that. It might be 1 to 10 in a day. So compared to this 10 lakh or 50 lakhs, 1 or 2 accidents in a day is very low. So the probability of getting accidents is very low compared to the number of vehicles traveling in the road. Okay, so there we say the probability of success is getting accident, that is going to be very small. Yeah, as I said, the success is small, but the number of trials what we are speaking now, it's very high. It's nearly to infinity, but it is not infinity. Okay, so the success is very small and the number of trials, what we say, of course it is a Bernoulli trial, right? It's going to be very large. So n is very large and my success is going to be very small. Now when I multiply this, np is going to be a finite quantity. It need not to be necessarily a large one. It's going to be a finite and it is a moderate value. So we'll take np is going to be a constant. So this is the idea of Poisson. Okay, and people say this Poisson distribution is associated with Bernoulli trials of rare events. Okay, so whenever there is a rare event, we always use what? Bernoulli distribution. That is, sorry, Poisson distribution. So it is great to see this Poisson distribution is going to applied in probability theory to lawsuits as well as the criminal trials, etc. Okay, for more information you can refer the books. Now I'll give some examples. You can see one by one. Okay, so radioactive elements, number of accidents, defective data or defective products in a manufacturing company, number of earthquakes, person who is dying in a very rare disease, etc. These are all what? It's going to be a very rare event and it is a negative event. Okay, so we can apply Poisson distribution. So now how elegantly Poisson take this. So the proof is not in our syllabus, so I'm just not omitting the proof and I'm giving you the formula of Poisson directly. The thing is, it's very elegant how we get the formula. Okay, so when you apply limit n tends to infinity, it's not like this, and finally you arrive into the formula of Poisson distribution. So e power minus lambda power x by x factorial, where x start from 0, 1, 2, etc. And e value, it is not needed now because we are using the calculator. And you see, this is the only parameter. In binomial distribution, we have two parameters. That is what? N and P. Here, we have the only one parameter. We take it as lambda. So Poisson depends on the only parameter lambda, guys. Okay, let's go. Mean is NP. Variance is also NP, because in binomial what we see, mean is greater than variance. Here in Poisson we say mean and variance are what? The same. And standard deviation, I said many times, it is always positive. It's going to be positive square root of NP. This is my standard deviation, guys. Okay, let's go into the problem directly. So Poisson distribution is a distribution of rare events. Okay, sometime the negative, like the negative thing is going to be my success. Okay, let's go into the problem. So a problem is given in a blade factory. There is a chance of 1 out of 500 for any blade to be defective. Great. So that means my probability of getting a defective blade, okay, defective blade is going to be my success, 1 by 100. Great. Now the blades are in packets of 10. So each packet will contain 10 blades. So now this is my N. So each packet is containing 10 blades. I'm going to deal with this 10. So use Poisson distribution to calculate number of packets that containing no defective, 1 defective, 2 defective respectively. That means in each consignment I'm going to buy what? 10,000 packets. So my capital N, here also there is a capital N, which is 10,000. So my lambda is going to be what? N into P. So my N is 10, my P is 500. So it's going to be 1 by 50, guys. My lambda is going to be 1 by 50. Okay, let's go into the problem. So as usual, we have to assume, let x is the number of defective blade. P is the probability of getting a defective blade. Just now I said P is going to be what? 1 by 500. It is very clear given in the question. So now we have to check how can I apply Poisson distribution. When it is 1 by 500, it is going to be 0.002. It almost tending to 0. Now it is eligible for what? It indicates that we use what? Poisson distribution. Good. Great. Let's go. So now, as usual, I said N is going to be number of blades in a packet. It is 10. So my NP, finally my lambda is going to be 0.02. Now problem over, guys, because we know the lambda. Just what you have to do. Then we write what is my capital N, 10,000 packets. Then immediately we write what? The formula for Poisson distribution, guys. So the Poisson distribution formula is this: e power minus lambda power x by x factorial. I'm going to substitute the value of lambda. Okay, now what you have to do, it's time for calculator. Okay, pause your video, take your calculator. So I already said to watch the calculator tricks videos. Hope everybody is ready. So take your calculator, pause the video and code it. Okay, so now you know how to code it. All the material, like all the details are available in the calculator tricks. So I'm just writing the data which is to be entered into the calculator. So we'll be getting e power minus 0.02, multiplication symbol is essential, 0.02 power x and divided by x factorial. So from the calculator tricks video, you know what are all the operators you use to this calculator. Now it is ready. So now keep your calculator, press equal to, then press calc for your value, what you are going to find. Let's go. Yeah, I've given everything in a table, very clear. So now when you press calc, okay, it will ask what is your x value. Okay, it will ask what is your x value. So our first question, what it says, 0 defective, 0 defective. If it is 0 defective, just put x equal to 0, you'll get the answer. Then the second question says x equal to 1, it's 1 defective. So now put 1, write the value here. Then press 2, write the value here, because the question says 0 defective, 1 defective and 2 defective. Now I want to know how many packets are there out of 10,000 with 0 defective. So this is obvious. We have this data. When you multiply, now we have to round off it. It's 9,802, because my n is what? 10,000 packets. We already known this data. Now when you multiply with the second probability, we get number of 1 defective blade packets out of 10,000 is 196. Similarly, number of blades with exactly 2 defective out of 10,000 is what? 2. The problem gets over, guys. So only the calculator plays a role here, nothing else. So problem 1, it's very simple. So now in Poisson, what are all the chances? They will ask you to find some probability. 2 chances we have. So either they will give the probability and n, or they will give lambda value. So we have to identify whether the question has lambda or whether the question has my number of trials and success p. Okay, you have to identify it, otherwise it will lead to a big trouble. Let's go. Let us see this question. In a turning out of certain toys in a manufacturing company process, a factory, the average number of defectives is 10%. Okay, many students, what they will do, whenever they see 10%, they close the eyes, they write p is 10%, because it is a percentage. Percentage means probability of success. So you lose all your mark. This is wrong. Why? Read the question very clear. The average number of defectives. Okay, it is very essential. What it is? Average number of defective. Whenever we say average, what is the other name of average? Mean, expectation. Okay, all these things. So my meaning of average here is what? NP. Guys, you should be very careful. It's mean. Okay, so problem over now. Why? You found lambda. Lambda is given as 10%. So it's simply 0.1. Hey, after this, nothing was there in the problem, guys. Problem over. So probability of getting exactly 3 defective toys. So they are telling you to find what? X equal to 3. That's not a big deal. In a sample of 10 toys chosen at a random. That's okay. So now the defective, you found it, and you can see this. Okay, that's it. So when you put x equal to 3, take your calculator, do the job, you'll get the answer. Okay, it's very simple. Is it clear? That's it, guys. Now let us go into the next problem, because this problem is very easy. What you do, you just find lambda, problem over. But if you took this as p, you are in trouble. Okay, so we should be careful about the problem. Okay, guys. Now let us see the next problem. A manufacturer of pins knows that 2% of his product is defective. Okay, good here. So here there is no average. 2% of products is defective. So my P is going to be what? 0.02. Okay. My N is what? My N is given. He sells pins in boxes of 100. So my N is 100. My P, I'll even keep it simply what? 2 by 100. It is easy for me to calculate. So my lambda value is what? N into P. So it is simple 2. Okay, good. Now it is done. Now let us see what kind of problem we are going to face. So lambda is 2. One can think, sir, problem is nothing. Now what you can do? You know the formula, simple. X equal to x, e power minus lambda, lambda power x by x factorial, because it follows Poisson distribution, because the probability of success is very low. So my lambda value is e power minus 2, 2 power x by x factorial. So what is the trouble here? Let us see. Let's go back to the question now. What is the probability? Okay, before that, he is selling 100 pins and the guy is guaranteeing that not more than 4 pins are defective. Wow. So he is betting that, or he is giving the guarantee that not more than 4 pins will be defective out of 100. Now what is the question? What is the probability that the box will fail to meet the guaranteed quality? Interesting question. Let's go and see the problem. So we found all the data what we need, right? We found lambda here. So the manufacturer says, like, we guarantee that more than 4 pins will not be defective. Fail to meet the guarantee means we have to prove number of defectives should be what? More than 4. So that means we have to find the probability that the products with more than 4 defective in a box of 100. That's what we have to do. That's it, guys. So let's go and do the process. So we write the formula. Just now we write. So now there is a big trouble for us. When I say more than 4 defectives, so I will have what? 5 defective, 6 defective, etc. I will have 100 defective. Even you have a calculator, it doesn't matter if you start solving up to 100, it takes a lot of time, right? It may take an hour at least. So now we go for a classical formula, because it is what distribution? It is a discrete random variable, it is a discrete distribution. So I use this formula. This is the privilege which I have. Okay, so now the problem is simple. If you go in this red way, it's too much. So now what I'm going to do, I'll simply omit this way. I'm going in this alternate way. Okay, guys, simple. Okay, so now x equal to 0 up to 4, you calculate, that is enough. Now let us take your calculator, guys. Take your calculator, crack the problem. Okay, so here already we have written lambda value. Yeah, so what you have to do? Yeah, you know everything, but still I'll tell for your sake what should you enter into the calculator. 2 power x divided by x factorial. Now go press calc. Before that, press equal to, then press calc and then enter the values. What the values we need? 0, 1, 2, 3 and 4. Okay, that's it, guys. So I'm doing it in a professional way. Now you can see. Okay, done. You can write like this, or you write the first term and then plus dot dot dot, you write the final term. That is also okay. Now what you do? Add all the terms from 0 to 4 and then subtract with 1. You'll be getting the answer directly. Okay, so probability of X greater than 4. So the guy is guaranteeing you that more than 4 defective blades. Now the probability is what? More than 4 defective blades is 5%.